All right, now we're going to cover 9.3 and 9.4. So 9.3 is about two-way tables. It says a two-way table displays two categories of data collected from the same source. You randomly survey students in your school about their grades on the last test and whether they studied for the test. The two-way table shows results. Each entry in the table is called a joint frequency. So pretty much a two-way table is just how we organize statistical data. And as you can see here, we have data that shows us which students studied and did not study, and how many of them passed and how many of them failed. Each of the entries are what we call joint frequencies. Okay, so make sure you have this in your notes. Okay, next we have marginal frequencies, the sums of the rows and columns in a two-way table. So go ahead and have this copied down into your notes as well. Okay, so here's the first example. How many of the students in the survey above studied for the test and passed? So here we see that we want to look at how many studied, and then we see that the number of students that studied are 21 and 1, meaning 22 students overall studied, but the only ones that actually passed were 21 students. So we see that 21 of the students in the survey studied for the test and passed. Here it says find and interpret the marginal frequencies for the survey above. Create a new column and a new row for the sums, then add the entries. Now, marginal frequencies, that's just another term that we use when we want to tally up the totals for each column or row. For example, if we add up 21 and 2, we would get 23, and that's the marginal frequency for how many students passed. 7 would be the marginal frequency for how many students failed. 8 would be the marginal frequency for how many students did not study, and 22 would be the marginal frequency for how many students studied. And 30, when we add up all these numbers together, would be how many were surveyed in total. It says you randomly survey students in a cafeteria about their plans for a football game and a school dance. The two-way table shows your results. First, how many students will attend the dance but not the football game? So we want to see how many are attending the dance but not attending the football game. And we see that we have 5 students. Here it says find and interpret the marginal frequencies for the survey. So if we were to add them up, we would see that 36 students attended the dance or did not attend the dance. 40 students did attend the dance. 25 students did not attend the football game. And over here, we could see that 51 students did attend the football game. So this is just reviewing our answers. 5 students. A total of 51 students will attend the game. A total of 25 students will not attend the game. A total of 40 students will attend the dance. And a total of 36 students will not attend the dance. All right, so here we have two sets of data for students that do ride the bus and do not ride the bus, and it's divided into separate categories of their ages, right? You have 12 and 13 years of age, 14 to 15, 16, 17. So now we're going to go ahead and create a marginal frequency table for this set of data. So go ahead and do that in your notes. All right, let's go ahead and go over the answer. So this should be the table that you created for these two tally sheets. As you can see, for age, we have the 3 separate categories. For students, we have rides bus, does not ride the bus. And we have the marginal frequencies. 50 students rode the bus, 50 did not. We had 40, 12 to 13-year-olds, 25, 14 to 15-year-olds, 35, 16, 17-year-olds. And overall, we had 100 students surveyed. It says for each age group, what percent of the students in the survey ride the bus to school? Do not ride the bus to school. Organize results into a table. Explain what one of the entries represents. So this is going to be different because now we're looking at percentage. And for percentage, you need to know that the total is 100. And all we have to do to get that percentage is we take the number of students So here it says 40% of the 16 and 17-year students in the survey ride the bus to school. They took 14 divided by 35 to get 0.4. So if we look back here, we see that there were 14 students that rode the bus that were aged 16 and 17 out of 35 students overall that were between the ages of 16 and 17. So that's how we would find the percentages. We would take the number divided by the marginal frequency. Take the number divided by the marginal frequency. And that's how you arrive at these answers. 60%, 48%, 40%, 40%, 52%, and 60%. Here it says, does the table in Part A show a relationship between age and whether students ride the bus to school? Explain. We say yes. The table shows that as age increases, students are less likely to ride the bus to school. And you see that. As a student gets older, they are less likely to ride the bus to school. So this goes down as age increases. This goes up as age increases. Okay, here we have some data. It says for grade 6 students, 11 pack a lunch, 9 buy lunch. Grade 7, 23 pack a lunch, 27 buy it. Grade 8, 16 pack it, 14 buy it. So you randomly survey students in school about whether they buy a school lunch or pack a lunch, and these are the results. So we're going to make a two-way table that includes the marginal frequencies. So go and do that in your notes. Okay, so here's the answer. So as you can see here, we go ahead and put the entries of 11 and 9 with a marginal frequency of 20, 23 and 7 with 50, 16 and 14 with 30, and the totals are marginal frequencies for this column here, 50 and 50, showing that we had 100 students surveyed in total. For each grade level, what percent of the students in the survey pack a lunch? Buy school lunch. Organize the results in a two-way table. Explain what one of the entries represents. Okay, so go ahead and do that in your notes. Okay, let's check your answers. Yeah, 55%, 45%, 46%, 54%, 53%, and 47%. Does the table in Part B show a relation between grade level and lunch choice? Explain. We say no. About half the students in each grade buy a school lunch. So as you can see here, it doesn't matter what grade they are. It's pretty much close to half of the student class will either pack a lunch or buy a lunch. All right, now we're on 9.4, choosing a data display. So this section pretty much talks about what type of statistical data display do we use for what type of data. So we have pictographs. Those show data using pictures. Bar graphs, showing data in specific categories. Circle graphs, shows data as parts of a whole. Okay, make sure you have this in your notes. Next we have a line graph, shows how data changes over time. Histograms, shows frequencies of data values in intervals of the same size. Stem and leaf plot, orders numerical data and shows how they are distributed. Okay, make sure this is also in your notes. Here we have the box and whisker plot, shows the variability of a data set by using quartiles. Dot plot shows the number of times each value occurs in a data set. Scatter plot shows the relationship between two data sets by using ordered pairs in a coordinate plane. Make sure this is also in your notes as well. Choose an appropriate data display for the situation. Explain your reasoning. The number of students in a marching band each year. So, of the data sets that we were shown, which of them would best match the number of students in a marching band each year? The answer is a line graph, which shows change over time. So a line graph is an appropriate data display. How about the comparison of people's shoe sizes and their heights? For this one, since we're comparing two different data sets, a scatter plot is an appropriate data display. Okay, so for your notes, go ahead and tell me what data display would be best used for each situation, and make sure to explain your reasoning. All right, let's check your answers. For number one, it would be a bar graph. For number two, a circle graph. It says that you record the number of hits for your school's new website for 5 months. Tell whether the data display is appropriate for representing how the number of hits changed during the 5 months. Explain your reasoning. So here we have a chart showing us how many website unique hits our website was getting for the months of August, September, October, November, December. And we need to know which data display would be the best one to use. So here we have a bar graph. And the bar graph shows the number of hits for each month. So it's an appropriate data display. Next is a histogram. And histograms, those mostly show frequency of data, right? How frequent something keeps showing up. So it does not show the number of hits for each month or how the number of hits changes over time. So it's not an appropriate data display. As you can see here, it's not really explaining to us how many hits we get per month. It's just telling you how many times we got 0 to 399 hits, how many times we got 400 to 79 hits. So it's not telling you what we got in a month, like month of January or February. It's just telling you how often these numbers showed up. And here we have a line graph. And the line graph shows how the number of hits changes over time. So it is an appropriate data display. Okay, so in your notes, I want you guys to tell me between these two graphs, which show you the same data, what is misleading about them? All right, so let's talk about this. Okay, both of them are talking about box office revenue, and the word revenue pretty much talks about how much money a certain movie pulled into the theaters, not counting profit or cost. Okay, so it's billions of dollars for both sides, and you have the same years for the x-axis. Now notice that we have this little symbol here, and that means it's jumping from 0 to 8, Whereas on this graph, you have 0, 2, 4, 6, 8, 10. And it shows us the difference every year makes in revenue. Now the thing is, these numbers are exactly the same as these numbers here. All right, it's showing us the same values. But the reason why this is misleading is because it shows you a very steep graph, whereas this one shows you a very flat graph. And why is that important? The reason why that's important is this. A lot of times when you are approaching investors, right, people with money, and you want them to buy your idea, you have to show them graphs of potential profits, right, potential money made. And a lot of investors like to see a graph that looks like this. Why? Because it looks like their money is increasing very rapidly, right? Like my money was here in 2005 and 2009, it's all the way up here. That means if I put money or if I invest in your company, I'll be making a lot more money very quickly. But if you show them a graph like this where, your money starts here and it kind of gets up to here, it's not very exciting. And they're less likely to want to invest because a flat graph doesn't really like spark interest as much as a steep graph would. See, so this is what we call a misleading graph or a misleading data display. Okay, in this example, it says a volunteer concludes that the number of cans of food and boxes of food donated were about the same. Is this conclusion accurate? Explain. So we look at this and it looks like the amount of canned food and the amount of box food is pretty close together, right? But as you can see here, one symbol for the box food equals 20 boxes, one symbol for canned food is 20 cans. So in actuality, there were a lot more cans donated than boxes of box food. But because of the type of symbol we used, it looks like they're about even. So each icon represents the same number of items. Because the box icon is larger than the can icon, it looks like the number of boxes is about the same as the number of cans. But the number of boxes is actually about half of the number of cans. So the conclusion is not accurate. All right, in your notes, go ahead and explain why this data display is misleading. Okay, so if we look at this, we see that tickets for A were $40, tickets for B were $45, and tickets for C were a little like less than 55, so about 53. And it's misleading because if you look at this image, right, and someone said, hey, do you want to buy ticket A, ticket B, ticket C? You would look at ticket C and think to yourself, wow, that's enormous. That's a really big symbol. Compared to ticket A, it must be really expensive. So, A, yeah, definitely I would want to just get A. But as you can see, the difference between ticket A and ticket C is only about $13. It's because they use such huge symbols that it gave it the illusion that ticket C was double the price of ticket A, right? Because it's double the size, but it's not. It's only $13 more. Okay, go ahead and explain why this data display is misleading. Okay, so as you can see, the width of each bar graph is increasing as you go from left to right, giving you the idea or the illusion that profit is getting bigger as well. But as you can see here, it's steadily increasing up to about 14, right? It's not having this dramatic increase, but because the bars are getting wider, it makes you think, wow, we must be making a lot more money than we were before. Here's another one. Go ahead and tell me what is misleading about this graph. And this one talks about gun deaths in Florida, the number of murders committed using firearms, and in 2005, they say they enacted its stand your ground law right here. Okay, so the reason why this graph is misleading is because it's upside down. 0 is up here, 800 is down here, where 0 should be down here. So it gives you the illusion that the number of murders went down after this law was passed. But in fact, murders went up. And this is an actual uh, data display that was used on a certain news network. All right, what is misleading about this data display? All right, so here it talks about Obamacare enrollment, and as of March 27th, they had 6 million, and March 31st was the goal, and the goal is 7,066,000, and it looks to be as if the goal is very far away from what they had, but as you can see here, 6 million, it's not that far from 7 million, but this graph here is 3 times the size. So it's misleading to the viewer, making them think that the enrollment goal is 3 times farther away than it actually is. All right, go ahead and describe why this graph here is misleading. Okay, so as you look down here, it says 2009 Q1, 2009 Q2, 2009 Q3, and pretty much all 4 of these bar graphs here represent the year of 2009. It's just been separated into its months. This represents months of January to March, April to June, July to September, October to December, right? And instead of showing just one bar graph for the whole year, they show you 4 separate bar graphs for each year. And why do they do that? To make it look like, for a viewer looking at this graph and not reading it, make it look like that a lot of welfare is being received in the US over this many years. That it started off very low in 2009, and suddenly in 2011, all this money has been received. So that's why it's misleading. All right. So what is misleading about this one here? Okay, so this is illegal immigrant federal convictions, and you have 18% drug trafficking, 30% kidnapping, 75% drug possession, 10% money laundering, 21% national offense, and 5% of murder. All right, so quickly, if you add all these up, you don't get 100%. You get way over 100%. And in fact, they're not really telling you what the percent is of, right? So 18% of illegal immigrants were caught for drug trafficking, or was it 18% of all drug trafficking were illegal immigrants? See, this is a very misleading graph and or a misleading data display. And again, numbers like these are used to confuse a viewer into thinking a certain way about illegal immigrants. All right, let's look at this one. 2012 presidential run. It says 63% back Huckabee, 60% back Romney, 70% back Palin, and as you can tell, this should all add up to 100%, but it does not. And in fact, it makes it look like Huckabee receives the biggest share of the pie when in actuality 63 is lower than 70%, but they make the 70% look very small. Here's another one. Did scientists falsify record or research to support their own theories on global warming? And you have 59% say somewhat likely, 35% very likely, and 26% not very likely. So why is this misleading? And you're right. All this should add up to 100%, but it does not. Here we have the unemployment rate under President Obama. Okay. And the reason why this is misleading is because 9%, 8.9, 8.8, 9.0, all of these are pretty much very close to the same number. But they have to use percentages or decimals to give it this graph that makes it look like it's fluctuating, going up and down, when actually it's just staying steady.